Imagine holding a piece of history in your hands, not just a stone, not just a shard of pottery, but a tool. A tool made by someone who lived, breathed and walked this earth 4,000 years ago. Now imagine that the glue holding this ancient tool together, a simple-looking black substance, is still working. It's not a fossil, it's not a mineralized remnant. It is a functioning adhesive, still sticky, still holding fast after 4 millennia of silence. This isn't a flight of fancy. It is a reality that is forcing archaeologists and scientists to tear up the old textbooks. We live in an age of incredible technological advancement, where superglues and industrial epoxies are created in sterile laboratories. We can bond steel, fuse plastics, and create materials that can withstand incredible forces. Yet many of these modern marvels have a limited lifespan. They become brittle, they degrade under UV light, they fail after a few decades. So how is it possible that a simple tar, cooked up over a fire by people we once dismissed as primitive, can outlast our most sophisticated chemical creations? Some of the earliest evidence comes from a site in Italy, Campitello, where traces of this remarkable adhesive were found on stone tools dating back an astonishing 200,000 years. This wasn't the work of Homo sapiens, but of our ancient cousins, the Neanderthals. But the evidence from a site in Königsauer, Germany, blew that theory out of the water. There, an 80,000-year-old piece of birch tar was found bearing the fingerprint of a Neanderthal, proving it had been handled and used as a purposeful adhesive. These were not isolated incidents. As archaeologists looked closer, the tar kept turning up. One of the most famous examples is Otzi the Iceman, the stunningly preserved 5,300-year-old mummy found in the Alps. Tucked into his belongings were flint-tipped arrows, their heads secured with expertly applied birch bark tar. Scientists began to investigate just how this tar was made. They discovered that it requires a highly controlled and sophisticated process. You can't just burn birch bark in an open fire. That simply creates ash. To produce the tar, the bark must be heated in an oxygen-deprived environment to a very specific temperature range, somewhere between 300 and 400 degrees Celsius. Experimental archaeology has provided incredible insights. Researchers have spent years trying to replicate the production using only materials available in prehistory. One popular theory suggests a pit method, where a hole is dug and lined with birch bark, covered with more bark and soil before a fire is built on top. The heat slowly bakes the bark below and tar trickles down to collect in a container at the bottom. Another method involves using 2 pottery vessels, one filled with bark, inverted over a second empty vessel, with the join sealed with clay. They had to know which part of the birch tree to use. The outer bark is best. They had to master fire to a degree we can barely comprehend, maintaining steady high temperature for hours. This is not accidental knowledge. It was passed down through generations, refined through countless trials and errors. The final product was a wonder material. It was sticky when warm, but hardened into strong, durable and waterproof adhesive. When modern chemists put ancient birch bark tar under the microscope, they expected to find a relatively simple compound. What they found instead has left them baffled. The tar is a complex cocktail of hundreds of organic compounds, including phenols, terpenes and long-chain polymers that we are still unable to fully identify or replicate. The glue exhibits a remarkable combination of stiffness and flexibility, allowing it to absorb shocks and stresses without cracking. One of the most mysterious properties is its incredible durability. The tar seems almost immune to the ravages of time. Samples taken from archaeological sites have been found to be chemically stable after thousands of years buried in wet, acidic soil. Modern adhesives often rely on volatile solvents that evaporate over time, causing the glue to shrink, become brittle and fail. Furthermore, some studies suggest the tar may possess self-healing properties. Tiny microcracks can slowly rebond, essentially healing themselves. The challenge for scientists today is that we cannot artificially recreate birch bark tar with the same properties. We can follow the ancient recipes and produce a similar-looking substance, but it never quite matches the performance of the archaeological samples. There appears to be a missing ingredient or a subtle step in the process, a dark art that was known to the ancients but is lost to us. The 4,000-year-old glue still holds its secrets close. The story of birch bark tar doesn't end with the Stone Age. The Vikings were masters of the sea, and their legendary longships were the key to their expansion. These ships needed to be light, flexible enough to ride the brutal waves of the North Atlantic, and most importantly, completely watertight. The secret to achieving this was once again a clever use of tar. Viking shipwrights would caulk the seams with animal hair soaked in a sticky mixture of tars. Birch bark tar was ideal for this purpose. It would move with the flexing of the ship's hull without cracking, keeping the sea on the outside. Ships excavated from burial mounds like the famous Oseberg ship in Norway still have traces of this original caulking. The Vikings used it for a vast array of everyday tasks: waterproofing leather, sealing barrels, and repairing everything from cracked bowls to leaky roofs. The production of tar became a significant industry in Scandinavia, with entire communities specializing in its manufacture. Even more striking is its performance across a huge range of temperatures. From the freezing winters of the Arctic Circle to the warmer climates of the Mediterranean, the tar remained effective. It didn't become brittle in the cold, nor did it melt in the heat. This thermal stability is a property that many modern sealants struggle to match, highlighting the genius of this ancient technology. The existence of this technology fundamentally changes our perception of the people of the distant past. For too long, we have pictured our Stone Age ancestors as brutish figures. It reveals a world of thoughtful, intelligent, and scientifically minded individuals capable of long-term planning and sophisticated problem-solving. Think of the cognitive skills required, first recognizing a problem, then imagining a solution. This requires abstract thought. This implies that ancient communities had individuals who were, in effect, specialists or researchers. This suggests a social structure that valued and preserved technical knowledge, passing it down through generations. It points to language sophisticated enough to convey complex instructions and concepts. This 4,000-year-old adhesive is not just an artifact. It is a window into the minds of our ancestors. They were, in the truest sense of the word, chemists and engineers. We stand today at a fascinating crossroads. Armed with advanced scientific tools, we are beginning to unlock the secrets of ancient technologies. The story of birch bark tar is a powerful lesson in humility. It reminds us that our modern world does not have a monopoly on genius. We are the inheritors of a legacy far richer and more complex than we ever knew. Its longevity is a product of a perfect storm of factors, a holistic masterpiece of natural engineering. If Stone Age people could master this level of complex technology, what else did they know? What other lost technologies are waiting to be rediscovered? Every artifact we pull from the earth is a potential page from a lost library of ancient knowledge. We are only just learning how to read the language in which they were written, the language of chemistry, physics, and materials science. The story of humanity is still being written, and many of its earliest chapters are yet to be fully understood. This journey leaves us with a profound question. As we continue to develop new technologies, what have we forgotten along the way? I urge you to look at the world around you with new eyes, to see the history buried beneath your feet. For in understanding the true genius of our past, we might just find the wisdom we need to build a better future. Subscribe for more ancient mysteries that challenge everything we thought we knew.